Welcome to part 1 of the World Composition video series. What this video series will do is teach you a lot about the details and limits of the Unreal Engine 4 World Composition system. I recommend watching the official Epic Games Getting Started with World Composition live training video prior to watching this series. This video series is the result of the culmination of months of tests and benchmarks of the UE4 World Composition for Engine Build 4.26.2. Note that your experiences with using World Composition may be different depending on the workstation hardware and the World Composition setup used. Some concepts and information in this video series will be repeated across separate videos so that each video is complete and can be watched as a standalone entity. World composition is a method for working on large worlds where the world is designed as a single persistent map with a folder of streaming levels. It includes such features as level streaming distance, level LOD generation, and world origin rebasing. World composition has simplified asset management and allows a team of developers to work on the project simultaneously. World composition is enabled in the main map's World Settings tab, World section, Enable World Composition checkbox option. The first rule of world composition is to keep things real. When first presented with world composition as a feature, many people exclaim, "I want to build an entire planet." Or the less enthusiastic may shout, "I want to build an entire continent." Well, here are some of the cold hard facts about working with large worlds. Let's examine just a small area of the Earth. Europe is about 5,000 kilometers by 5,000 kilometers, or 25 million square kilometers, when rounded up into a square shape including the surrounding ocean, which is 5 million meters by 5 million meters, and therefore 500 million by 500 million Unreal Engine units in size, which is in centimeters. 16-bit terrain height maps at 1 meter spacing are going to be 50 terabytes in file size. This is just for the source height maps. The project file size becomes about 10 times larger after importing the tiles into the Unreal Editor, so 500 terabytes or more. You won't want to use static lighting, or you will increase that file size again, so 800 terabytes with light maps depending on the light map resolution chosen. Hurdle number 1 is the sheer file size for just the terrain alone. I hope that you have a 1000 terabyte drive to work on, and stacks of external drives for backup. For this 25 million square kilometer world, if you split the terrain into 8129 by 8129 tiles, which are the largest size that you can use, you will have 615 by 615 tiles, or a total of 378,225 tiles to import into Unreal Engine. So basically almost 400,000 Heightmap tile files to manage. Hurdle number 2 is the tile count and management. I'm betting that UE4 or UE5 chokes on way fewer tiles than 400,000. Hurdle number 3 is going to be finding some software that supports and allows creating a 25 million square kilometer height map and splitting it into 400,000 tile files. This is why large open world games do not typically use height map based landscapes like what Unreal Engine has for a terrain system. They often use custom TIN, also known as triangulated irregular network style mesh systems. This is so that they can optimize triangle detail and cut down on the memory and file requirements by a factor of 1,000 to 10,000 or more. If this is your first foray into using Unreal Engine 4 World Composition, then start small with something between 64 square kilometers and 256 square kilometers. 64 square kilometers is an 8 kilometer by 8 kilometer world, and 256 square kilometers is a 16 kilometer by 16 kilometer world. Anything larger than that balloons up in size and system requirements rapidly. In this world composition video series, we will be working with world sizes up to 32 kilometers by 32 kilometers, which is 1,024 square kilometers, and beyond, up to the maximum memory that my workstation has available. To give you a real-world example of the magnitude of a large open-world project, a project with just terrain and an auto material of 3 layers with 8 textures, no meshes, no level tile streaming LODs, with a landscape of 32.5 kilometers by 32.5 kilometers, which is a total of 1,057.3 square kilometers, has a project file size of 6.01 gigabytes and a packaged build file size of 9.72 gigabytes. The project specified is using 4x4 tiles, which is a total of 16 tiles of 8129 by 8129 size, which total 2.1 gigabytes just in Heightmap files. Adding tile streaming LODs will double the total size of the project. Importing the 16 8129 by 8129 tiles required 14 gigabytes of memory. Loading all 16 tiles into memory for editing consumed more than 72 gigabytes of memory. A packaged build of the project, which is terrain only, is over 9.7 gigabytes in size. Here are some additional size requirements. Also, for an equal world size, the amount of memory required for importing the tiles and for loading the levels increases as the number of tiles increases. So a 1024 tile, 256 square kilometer world will require more memory than a 256 tile, 256 square kilometer world. The persistent level is the main level that contains all of the world composition levels. You can think of it as a parent of all of the child levels. Any actors placed into the persistent level will be present in all levels. Typical actors placed into the persistent level are the main skylight and main light source, the atmospheric fog, and any other actors that you want to have automatically be present in all of the levels. For the Unreal Editor file layout, the persistent level is the main map file, while the levels are in a folder under the map file location that is named with the tile file prefix. The levels are all of the independent tiles for the world, either created manually or through the Import Tiled Landscape feature. The Unreal Editor places all levels into a folder based on the tile name used. Any LODs created for each level will then be located in a subfolder with that level name underneath the level folder. If the tiled landscape importing messes up or the engine crashes during tile import, it is totally safe to exit the editor and delete the levels folder, then retry the import process over again. The engine scans for the levels folder during map loading and automatically inherits all child levels at that time. So deleting all levels while the editor is closed will not result in broken references in the main persistent level map. I don't recommend using baked static lighting with world composition. Instead, use dynamic lighting. The map built data UAsset file for an 8129 by 8129 landscape with dynamic lighting is 1.13 megs. The map built data UAsset file for an 8129 by 8129 landscape with static lighting using the default light map resolution is 1.02 gigabytes. So on a 64 kilometer by 64 kilometer world composition, with 8 by 8 or 64 total 8129 by 8129 tiles, the total additional space for the light maps would be 64 times 1 gig equals 65.28 gigabytes, and a really long time to build all of those light maps. Disable light maps by setting the light source directional light to movable instead of stationary, and all other lights to movable. And in the Maps World Settings tab, set the Light Map section's Force No Pre-Computed Lighting to Enabled to disable light maps. The landscape height map is a square or rectangular area of 16-bit integer data that equates to an XY grid of elevations. When viewed as a grayscale bitmap, the color black is the lowest altitude, the color white is the highest altitude, and all of the grays are elevations by value. A 16-bit height map's integer data results in 65,536 total elevations. The Unreal Engine Landscape System can import terrain files in PNG 16 and RAW 16 file formats. I strongly recommend using the PNG format since it is a much easier format to use, since RAW files are simple headerless binary data streams with no internal format header or dimension information. PNG 16 files are also using lossless compression, so the PNG files will be smaller on disk than the RAW files. Note that if you are using Photoshop to work with landscape terrains, its 16-bit grayscale mode is actually 15 bits plus 1, supporting only half of the total 16-bit elevation range. This results in height maps edited with Photoshop having a data range of 0 to 32,768 instead of the full 65,536 range that 16 bits supports. So half of the elevation data precision will be lost if you are using Photoshop. The Landscape Actor supports height maps up to 8129 by 8129, or roughly 8K by 8K, assuming that the recommended landscape height map sizes are chosen. At the default landscape scale of 100 centimeters, or 1 meter between pixels and vertices, that is an 8 kilometer by 8 kilometer area, which is 64 square kilometers. Real-world land area is always classified in square kilometers. It is never in kilometers squared, so you should always use square kilometers to avoid confusion. The maximum height map size that can be imported is 8161 by 8161, which is a section size of 255 by 255 quads, 2 by 2 sections per component, and 16 by 16 components for 256 total components. Each component is converted and stored into a power of 2 texture in the engine. When rendered, each component will be a rendering draw call. So an 8161 terrain will require 256 draw calls to totally render the terrain. Attempting to import a height map that is larger than 8161 will be clamped at that size. The recommended optimal landscape height map sizes are 127, 253, 505, 1009, 2017, 4033, and 8129. These values have the most optimal number of quads, sections, and components. Other dimensions can be used but should be avoided unless absolutely necessary and proper performance testing has been performed. There are 3 intermediate dimensions that can be used that also perform well, which are 1513, 3025, and 6097. These dimensions are also available in the TerreSculptor Unreal Engine Landscape dialog under the recommended sizes and also in the World Composition set. However, these are not on the approved list on the Epic Landscape Technical Guide documentation. They will still perform very well if you are requiring an intermediate dimension between 2 of the recommended sizes. I have tested these intermediate sizes of 1513, 3025, and 6097 with both landscape and world composition. The ability to use these sizes opens up the possibility to have additional total world dimensions, such as 8x8 tiles of 6097 for a 48K world size. The world composition system supports tiles using the recommended optimal landscape Heightmap sizes of 127, 253, 505, 1009, 2017, 4033, and 8129. It also supports the intermediate optimized sizes of 1513, 3025, and 6097. These are typically the only sizes that should be used for tiles, since they are the optimal number of mesh quads, sections, and components. The maximum size of a landscape tile is 8129 by 8129, or roughly 8K by 8K. At the default landscape scale, that is an 8 km by 8 km area, which is 64 square kilometers. World composition will use multiple tiles in an XY grid to extend the total world size. Worlds up to 128 kilometers, which is 16,384 square kilometers, should be possible if given enough computer system memory and drive storage. But realistically, worlds equal or less than 64 kilometers, which is 4,096 square kilometers, are most likely all that you will be able to work with successfully, even with a large workstation with 256 gigabytes of memory. See this video series, Part 5 Maximum Size, for information on world maximums and estimated file and memory requirements. I do not know if there is a maximum number of tiles that can be imported into world composition defined within the engine code. You will probably encounter running out of computer system memory or other editor crashes long before you can get to a high tile count. To test the Unreal Editor tile count maximums, I have successfully imported a 128 by 128 tile set, which is 16,384 total tiles, of 253 by 253 size tiles, which is a 32 km by 32 km terrain. Importing the 16,384 tiles required more than 5.5 hours on my computer, which is an R9 5950X, Asus ROG X570, 128 gigabytes, RTX 3080 with NVMe drives. During the importing of the 16,384 tiles, the Unreal Editor consumed more than 33 gigabytes of memory. Loading all tiles then consumed a total of 89 gigabytes of memory. Loading or saving all of the levels takes more than 10 minutes on an SSD-based system. The final project on disk is 31 gigabytes, and this is without any meshes or foliage. I won't be testing a 256 by 256 tile set, since an estimated time to import would be 1 or 2 days. Be careful using high tile counts, since the editor is prone to crash as counts get higher, and waiting 3 hours for a tile import just to have it crash near the end is frustrating to say the least. Note that if the engine crashes during tile importing, you can safely exit the editor, delete the levels folder, and retry the tile import again. Be aware that system memory requirements and drive storage space will increase dramatically as more tiles are used. After removing those tile sizes that typically cause visual hitching, which are 8129 and 4033, that would place the world composition maximum world size at somewhere around 16,384 tiles of 2017 for a total of 258 kilometers per area side, or 66,000 square kilometers, or more likely 16,384 tiles of 1,009 for a total of 129 kilometers per area side, or 16,000 square kilometers. The 16,384 tiles of 2017 by 2017 Heightmaps would require 133 gigs just in Heightmap tiles on disk. The 16,384 tiles of 1009 by 1009 Heightmaps would require 33 gigs just in Heightmap tiles on disk. Note that it is highly unlikely that all 16,384 tiles will be able to be simultaneously loaded into memory for editing on even a high-end workstation. since that would require hundreds of gigs of memory, so you would be limited to loading and editing a small section of the world at any one time. The tile sets are named with suffixes that specify the XY relative location in the tile set. For example, my tile x0y0 through my tile x7y7. The XY numbering sequence is the relative location of each tile in the set. It is not the location in the world. The tile coordinates offset value on the Import Tiled Landscape dialog determines the world location when importing. If you are loading in multiple tile sets, they should all still be using the same XY naming system but with a different base name, such as tile set A x0y0 and tile set B x0y0. You can import one set and then drag them out of the way in the world composition dialog, or use the tile coordinates offset on the import dialog to place them at differing world locations. Then adjust the tiles as required in the world composition dialog to obtain the file layout. This method allows creating multiple islands, for example. The World Composition Tile Importer includes a Tile Coordinates Offset property, which will typically be used to center the landscape terrain in the world. By default, Unreal Engine imports the tile set with the tile x0y0 corner at the origin 00 location, so the terrain is always in the positive coordinate quadrant instead of being centered in the world. To center the tile set in the world, set the tile coordinates offset to half the number of tiles in each dimension. This property is in tile counts and not in world coordinates. So if you are importing a 16 by 16 tile set, the tile coordinate offsets would be -8, -8 to center the tiles in the world. If you are importing a 32 by 32 tile set, the tile coordinate offsets would be -16, -16 to center the tiles in the world. Be sure to specify this offset as negative so that it moves the landscape tiles into the negative quadrant for centering. Note that the offset property can only be a whole number, so odd number tile sets such as 3 by 3 and 5 by 5 cannot be exactly centered on import, in which case just use -1 for 3 by 3 and -2 for 5 by 5, etc. The tiles can then be loaded, selected, and dragged closer to the center using the World Composition Minimap dialog. The landscape scale settings on the Import Tiled Landscape dialog are the same engine scaling system that a regular landscape actor uses. The scale values are in centimeters, with the default scale being 100 centimeters or 1 meter between landscape vertices. After importing a tile set, you cannot change the scale values. So if the scale Z for the landscape tile elevations is not set correctly, you must delete the levels folder and re-import all tiles again. When you are importing tiles for a world composition, you must set the landscape scale values at that time. You cannot change the landscape scale values on the levels after the import. So it is a good idea to use TerreSculptor to check the terrain height using the terrain scale properties to be able to choose a good scale Z for the Unreal Engine tile importer. TerreSculptor scale values can be set to match Unreal Engine so that the terrain in the viewport matches its size in all dimensions. This way you can transfer the TerreSculptor spacing Y value over to the Unreal Editor landscape scale Z value on the import dialog to correctly scale the landscape in Unreal Engine. With world composition, I recommend using auto materials unless there is a specific reason otherwise. If you use externally generated splat maps or weight maps, they have to be split into tiles along with the height map. Weight maps and splat maps are a lot of work if you have a high tile count, as there will be an equal number of weight map or splat map files to the Heightmap tiles count. With a 32 by 32 tile world composition, which is 1,024 tiles total, then you would also have up to 1,024 material instances that must be created and set up, which is a significant amount of work. Multi-biome texturing becomes even more difficult since you cannot easily use such features as the global biome mask without splitting it per tile, and biomes that end on the hard edges of levels will look terrible. Auto materials will be easier to use since you simply assign them to each level and they automatically calculate the texturing based on the terrain triangle data. However, auto materials cannot do fine detailing such as erosion flow lines and filters such as concavity for dips and pools. Landscape materials can be assigned in the level streaming proxy actor for each level in the landscape material slot. This video will not discuss runtime virtual textures available in Unreal Engine since that is another topic of its own. At the landscape default scale XY values of 100 Unreal Engine units, which is 1 meter, each tile size has the following view distance. This value should be known since it is relevant to the level streaming distance set in the World Composition Minimap dialog. The default level streaming distance is 50,000 units, which is 500 meters, or 1/2 of a kilometer. If a tile size of 1009 was chosen with the default level streaming distance, then the next adjoining tiles will be streamed in when the center of the current tile is approached. Level streaming is a method of loading and unloading levels on demand for performance optimization. Level streaming can also be used without world composition by using level streaming volumes. With regards to world composition, level streaming is used to only render the levels that are within the specified streaming distance. Level streaming is managed automatically by world composition using the level streaming distance settings in the World Composition Minimap dialog. Multiple streaming distance settings can be created, and different levels can be assigned to each setting. Individual levels will appear on the tab for the streaming distance that they are assigned to in the World Composition Minimap dialog. The level streaming distance value is in Unreal Engine units of centimeters, so a level streaming distance of 50,000 units is 500 meters or 1/2 of a kilometer. The default uncategorized level streaming distance is 50,000 units. The level streaming distance chosen is usually based on the level sizes that are being used and the view distance that is required. If the project requires a view distance of 2 kilometers, then a level streaming distance of 200,000 could be used. A view distance of 5 kilometers, which is common for large worlds, is a level streaming distance of 500,000. Note that levels that are assigned to the uncategorized layer in the World Composition dialog can also be controlled via blueprints. Level LODs are level of detail mesh proxies that are rendered at specific distances from the camera. These proxies, according to the Epic documentation, include static meshes, foliage, and landscape. However, static mesh LODs no longer seem to work in later engine versions. To create LODs for one or more world composition levels, choose the levels in the Levels dialog and click on the Level Details button. In the Level Details, the LOD Settings section defines the LODs for those selected levels. Up to 4 LODs can be generated for each level. Each LOD has a relative distance property that determines its streaming distance. So up to 4 LODs can be streamed at further distances from each other, such as LOD1 at 50,000 units, LOD2 at 50,000 units past LOD1, LOD3 at 50,000 units past LOD2, and LOD4 at 50,000 units past LOD3. The static meshes on the level are decimated according to the static mesh details percentage. The level landscape tiles are rendered into meshes at landscape LOD 0 and then decimated by the specified landscape export LOD number. Each level LOD will appear in a folder under the persistent level map levels folder. Each LOD will include a map file, a diffuse texture and a normal map texture, a material, and a static mesh. The assets created for each LOD can be previewed with the standard Unreal Editor asset editors. See the video series Part 3, Streaming and LOD for more information. The engine's maximum world bounds is 20.97 kilometers by 20.97 kilometers, as defined by the world max constant, which is in engine units, as defined in the engine defines H header file. Objects in the world can be placed from half world max to half world max, which is from minus 10.4 kilometers to plus 10.4 kilometers, or plus minus 10.48 kilometers. The world bounds exist because placing actors outside of the world bounds results in floating point precision errors. The world bounds affects all actors and will delete actors that go outside of the world bounds. The world bounds limit will keep your player constrained to an area of 439 square kilometers based on the center of the map. The world bounds checks can be disabled in the Map World Settings tab in the World section using the Enable World Bounds Checks checkbox option. However, this should only be used to prevent Unreal Engine from deleting specific actors that go outside of the bounds. World bound should not be disabled in an attempt to get a larger play area, since the floating point precision errors will cause actor locations and physics to jitter. In this example, I have created the first-person template both in the default world location and outside of the world bounds. You can clearly see that even the code to bob the weapon is now jittering when outside of the world bounds. When creating really large world compositions, such as larger than 32 kilometers by 32 kilometers, the sky sphere will have to be adjusted in size. The default sky sphere edge at a scale XYZ of 1.0 is at world location plus minus 1,638,402, which is 16.38 kilometers on each side of origin. A 32 kilometer world will be equal in size to the default sky sphere. The maximum realistic extents of a landscape with world composition and no world origin shifting is 32 kilometers by 32 kilometers, assuming that you require the long view distance of 6 kilometers around the perimeter past the maximum world bounds. A typical 32 kilometer by 32 kilometer world composition would be 32 by 32 tiles, or a total of 1,024 tiles, of 1,009 by 1,009 Heightmap tiles, which is 32.288 kilometers per side, or 1,042 square kilometers. To get a world composition larger than 32 kilometers, you must enable world origin shifting. This is because the maximum world bounds are set in the engine to 20.97 kilometers, since placing actors outside of the world bounds results in floating point precision errors. So for a fixed world origin, it is pointless to create a world composition that is larger than 32 kilometers if all actors are constrained to the center 20.97 kilometers. The world bounds are plus or minus 10.48 kilometers, so a 32 kilometer world composition setup would be plus or minus 16 kilometers, or about 6 kilometers of extra view distance on the horizon. Also note that in my tests, a 32 kilometer by 32 kilometer world required more than 74 gigs of system memory to create and manage. The maximum world size that can normally be created is determined by the maximum world bounds of 20.97 kilometers. This is a hard-coded constant in the Unreal Engine source code. At this distance from origin, floating point precision errors cause jitter in actors and animations. To get around this maximum world limitation, World Origin Rebasing allows for origin shifting all actors around the new origin. World Origin Rebasing is technically only required to be enabled if the world composition play area will be larger than the maximum world bounds of 20.97 kilometers. World Origin Rebasing is an option within the World Composition settings on the World Settings tab. The Enable World Composition checkbox option must be enabled before the World Origin Rebasing option is available. The default World Origin Rebasing distance from origin is the world bounds of 20.97 kilometers. If you are creating world compositions that have a main play area that is 20 kilometers or smaller, then there is technically no reason to enable world origin shifting. The World Origin Rebasing feature can be controlled with blueprints or C++ code. The functionality of the blueprint nodes is to take the player's current position and reset the world origin to the player's current position. World Origin Rebasing only works directly in single-player games. It is not supported in multiplayer without additional custom code.